Still computing with my laptop. This is my very first laptop, my 1997 Thinkpad 385 CD. The reason I got it was because it was basically obsolete by the time it was built. It's so low specification that ThinkWiki doesn't even have a listing for the 385 CD. This thing didn't even come with its own manual nor its own CD. It just came with the Thinkpad CD or the Thinkpad D components. This was a disappointment. Growing up with this laptop was difficult, and it was difficult to get anything to run on it, and then also difficult because it didn't actually run on the battery because it was a nickel metal hydride battery, very difficult to use. I always dreamed about having the Pentium 2 version, the 380Z, and I finally got one. It has a 300 megahertz Pentium 2. It runs Half-Life. It does a bunch of stuff. And what's interesting is it actually has similarly shaped, but it's a lithium ion battery, and that takes 18650 cells, which I have a plethora of from my electric bicycle projects, and I can replace these nickel metal hydride cells with lithium ion cells perfectly fine. I'll just have to get a little circuit just to make sure they don't get overcharged, but this one will have the circuit already in there. So swapping these out for lithium ion should be super simple. As it is right now, this has been charging for several days now as I've been tinkering with it, and it is completely dead. This one used to actually hold a little bit of charge. It would run for like 5 or 10 minutes, but totally dead too. I think we should focus on using some of my spare lithium ion cells and reviving the one for the new laptop, which I'm all excited for. And then someday in the future I'll find just the right circuit so we can modify the 385 CD so it as well has lithium ion in it. But for now, I want to do it with this battery. It's actually really funny. I wouldn't have this knowledge of lithium ion batteries if I didn't, and I wouldn't have had that job at Apple if I didn't have a ThinkPad X20 after that 385 CD. And the ThinkPad X20 batteries, oh mosquito, were so cheap that I bought 20 of them off of eBay in like 2011 or whatever. And then I started hacking them, messing with the cells. I opened them up and discovered they had cells in them, and that's when I first made my first electric bicycle, and we know where that's gone. And ever since then I've been hoarding lithium ion batteries for projects. Thing is though, my e-bike batteries I made are still lasting. They've taken me thousands of miles. So I start off with lithium batteries that I get, such as this, that have lithium cells inside of them, and I carefully open them up. And then I have several boxes of these, which I was gearing up to make a big battery pack, but as I said, I just never needed it because my other battery packs still work. I went through and I found 6 cells that are roughly 2000 milliamp hours of capacity. I made a little guide, a little several page booklet called The Tinkerer's Guide to the 18650, which I'll link in the description down below, but it goes over how to test these. Suffice to say, if these cells, if you find them below 1 volt, don't use them, because I had a few issues where a few bike batteries almost blew up on me because of those cells. Once they are found so low, they're likely to explode on you or go full short. So then what you want to do is you want to get like a cheap IMAX B6 battery tester, and those are everywhere. There might be better ones now, but those are the ones that I got a bunch of. And it'll allow you to actually charge up the cell, and then it'll drain the power and count of how much power, how many milliamp hours. This one's 1816 milliamp hours. And so you can go through and test them. Usually in a battery pack, like if it's a 12 volt pack, it'll usually have like 2 in parallel and 3 in series, so 3 packs of 2. And usually just 1 pack out of the 3 will be bad, and the other ones will be good. So you can go through your battery packs, rip them open, and then usually most battery packs, even if they're old laptop battery packs, will have a few cells that are still good. So These were good a few years ago. Let's test if they still are. So these have been sitting for a very long time. A lot of people like to test like internal resistance and whatnot, but I like to just test whenever you're charging the cells. If they get too warm to the touch, bad. And if they discharge over several months, that's also bad. These have been sitting for a year, and if any of them have a real bad issue, they would have fully discharged. So we have 3.5 volts, very good. That's how it's charged. 3.4 volts, very good as well. 3.5, 3.6, 3.6, 3.6. Oh, okay. These CGR 18650E cells, those, or those, they're name brand cells, so these are, of course, are going to be better. And these ones are just generic. LG, and then this one is Sanyo, and this one's LG too. I think this might be Samsung cells. You can look them up with the code numbers, so you can demystify some of those. But I'm not surprised that these orange ones work better. Oh, and just as a rule of thumb, it seems like these red ones are just, they are very hit and miss. I don't know who makes them, but it seems like red is just the designator for cheap lithium cells. I mean, they'll still get you around town, but just don't expect a whole lot from them. So I've tried to put in the vise and crack it. It hasn't really bonded. Looking at the other one, I remember I had to really destroy the top piece in order to get it off. So I'm going to try sawing. What am I doing? Oh no. Oh, we got it. So it appears the cutting it did make enough of a lip that I can latch onto it. Oh, it's different. This one has 7 cells, and this probably one has 6 in it. There we go. So that was the best way to do that. I was able to save the top this time. Well, I'm getting excited about this. Nice. See, that's the circuit I need. This one doesn't really come with much of a circuit. That's the circuit I need. Oh, and I already see some issues. So you can see that there's some discoloration underneath that label. That's a bad cell. And yep, 6 cells. So I got enough out. Let's start off by seeing what the voltage is. So 0.1, 0.1, 0.9. Yeah, these are dead. These are really dead. Now watch out, the stuff that's leaked out of this can kind of burn your skin, so make sure if you get any on you and you feel like this tingly feeling, go wash your hands. Yeah, it's actually, oh, it's actually rusted the connector off. Look at that. Well, okay. So, thankfully it hasn't spilled too much in there. So that looks like that's one of the cells that drug it down. I'm going to go get a pair of pliers now. Oh. Oh, wow. These are CK7P4B cells. Never seen those. So it's positive further out, negative towards that. Good. You don't want to be this rough to the cells if you plan to use them, though. Just FYI. And I'm only doing this because they're at almost no power. If they had any bit of voltage, even 2 volts in them, I wouldn't do this. But at 0.9 volt, they're less of a chance that it's going to have any effect. They don't really have enough energy to cause a fire. Alright, so now I come to another important relevant part that I've made a video about, but it's been like half a decade now. So you have various cells that you've tested to various sizes. How do you group them up? Well, it occurred to me, you line them up from lowest to highest, and then take these 2 cells, they'll be together. And you take these 2 cells, they'll be together. And you'll take these 2 cells, and they'll be together. That way, any cells that are really low will be coupled with ones that are really high, and they should average out. Let's see how that goes. Oh, damn. So, this is a really good example for this. I didn't expect to get this lucky. So, this is 4,036 milliamp hours, 3,997, 4,090. So that's only a difference of 100 milliamp hours between these two, despite them having a difference of 400 milliamp hours from lowest to highest. But since we grouped it with lowest and highest, second lowest and second highest, and then third lowest and third highest, we now have these packs almost entirely like lined up. At least good enough for free junk that I got from a recycling center and ripped out and put into a 1998 laptop. So I will want to put these into here. I'm going to make these lined up. And then, as long as you have a hot enough soldering iron, you can solder directly to lithium ion cells. But you just want to make sure you're very quick and use a lot of flux and do it right. Because you don't want to have too much heat go into the cell. Crank your soldering iron up to maximum temperature and then just try to hook it on there as fast as you can. And I haven't had any bad issues with that yet, but you gotta be careful with it. If you smell any like sweet smell radiating from these, you probably shouldn't use them. I don't know if I've ever seen a pack where all the cells go in the same direction. That's actually pretty cool for what I'm doing. Alright, so since it's only 6 of these, the placement that way isn't too bad. I forgot there's a little bit of room there, so that's good. So we can just kind of center it in the middle of that and be fine. I didn't want to make it off a little bit. That would have been unfortunate. I had to sandpaper that one because it was the one that was all rusted up. But that should fix it enough. Thought a little droplet of lead went into the end there. I didn't want anything to go wrong. Well, my soldering's getting better, that's for sure. The batteries got shifted over because of this first cell. I kind of messed up the placement. And the last one doesn't have enough tab to really connect. Oh, that is absolutely twisted up. Oof. These little tabs in here are giving me a little bit of an issue, so away with you. That was my mistake. I didn't solder it correctly. This is definitely not meant to be rebuilt, that's for sure. It doesn't turn on its own, which I hope it would, but oh well. I crammed the battery in there. I need to resolder it, and I decided to get the 385 CD disc, which I remember the Lazy Game Reviewers was going to do something about, but I finally copied it over. Oh, and I can't even open it. That's unfortunate. But at least I have backed up my Thinkpad 385 CD disk image. But no idea how to open a .lst. Apparently Windows 95 would understand that, but Windows 2000 doesn't. So, oh well. I was hoping I could get... No idea how to use this then, if it's only a .imz and a .lst file. I'll have to figure this out. I can't figure out how to load these. But anytime you have to open up a command prompt with a computer, I think you pretty much lose. Everything should be in the GUI. But here's the moment of truth. Can I pull out the cable and does it keep power? Nope, it does not. Okay, so... Alright, I'm going to try to salvage this a little bit. That's much closer. Now I just got to move these over a little bit. So I shifted them all over as much as I could. Tried to straighten it out more. It fits better. This sensor was skewed off a bit because I did get it soldered wrong. So I'm going to hold it down and solder it better. I burned myself and all this stuff, so I'm not really having too much of a good time, unfortunately. And it's not detecting this as a useful battery. That's what's bugging me. 3.63. 3.63. 3.52. So I put it back in, and it seems to fit nicer now. It's actually usable. I'll need to glue it if I do settle on anything that works, and if I trust that enough to not explode. Let's see, it's been a little while, still says 0, and damn. What a tight fit this thing is. .63, 3.63, 3.51. Yep, or 3.52, I mean. Looks like it's not charging whatsoever. So I'm going to have to find a way to reprogram that chip, or just replace it, which replacing it would be good, but then I wouldn't be able to see how much power it has in it, and the computer probably wouldn't like that. It'd be nice to know the reading from it. So I'm going to have to look that up. That's unfortunate. I've done so much with this today that I'm starting to mess up and burn my fingers with the soldering iron and such. So that's a good time to quit, especially whenever it's a big roadblock. What a shame. What a real shame. It's a shame these weren't good enough to use, but oh well. Just realized there is a bad connection right there. Oh, it's like entirely gone. Oh, so that's why. This really high wall made it so it tore the cable that was shortest, and that was the shortest cable. I know exactly the moment it happened too. I was putting it together and pop, the middle part was tense, and then it went pop and it popped in. It must have been that. It must have. So it's been a day, and I was talking to my friend Steve, and he was like, I thought I remember there's a way you can actually jumpstart them. And then I looked it up, and I found this video, which I saw years ago, but forgot about. So it's possible to jumpstart the positive on the inside of the positive on the outside. And that was kind of interesting, is in the comments, I saw a familiar face, a longtime viewer. So she says that you do lose safety in some of the boards. So that's a very important thing to keep in mind. So I'm going to make sure it charges right and charges safely. Oh, and I had it on for about 8 hours last night, and it did not accept the charge. Difference between 9 volts there. I'm trying to figure out how the power goes. I believe it's probably doot. And so this because of this voltage difference there. So I've looked through the traces, and I've flipped it over and watched how the traces go. And so this is negative and this is positive. 10.78 volts. Good. And so then if this is negative, then this should be positive. So then what we do and I'm worried about this, but we take from here and put it onto there. And then oh, it's like a few volts now. Let's do that into there. Longer. I have to do it in the computer. I don't know if that would play a part. Why do jumpers suck so much? Unfortunately, trying to plug it in, it's really difficult because now that's the one that's on the back side, so I have to fully flip it over. .01 volts. 3.63. 3.63. 3.52, because it will not accept power from it. Even if I jump it, the battery, or the laptop will not accept raw power directly to it. And, oh well. Now I still recommend you trying this on your laptop, because like with the Thinkpad X20, you could do this 100 times and it was fine, but for this one it just didn't have, they didn't want it to be able to do that, and they designed it to where once the battery loses power, this one needs to be reprogrammed in order to be used again. So that's unfortunate. Last try. Can the thing even run off of 11 volts? It can. So why can't I jump it? What the fuck? What is going on? It pulls 1.2 amps. So what is going on then? What in the world is going on? Oh, it's negative. So okay, now it works. It reads the battery is very low. Very, very low. Has flashing light. But it did start. Okay, so with jumping past the BMS circuit, it says 40% charged. I'm going to remove the power with the jumper still in. It goes dee-doot, and the light's green. But here's the question. Can the thing wake up? Will it still stay on if I remove the jumper? Nope. So the circuit is dead. The circuit is just plain straight up dead. Okay, so over these three brown things, there's 3 volts, 7 volts, 11 volts. So these are obviously voltage. But since there's a voltage difference across them, these might be fuses. And then I looked up this S8233AG, and it is a voltage, like a battery manager. And I'll have to look into this. So it is 14 pins, so it's the right thing. Floating detection circuit. overcharge delay circuit, over discharge delay circuit, overcurrent delay circuit, overcurrent detection circuit, overcurrent delay circuit. So if there is a voltage between these across those, I would think it'd be capacitors. But is there any fuses on here like that? Or any of these things? Could there be fuses that have blown? Looks like these little chips here are MOSFETs, and I measured the power across them. They are getting power. So those aren't the problem. I wonder if either of these are the problem. I believe these brown things are capacitors, so they aren't really something to worry about. I'll have to look up what that is. If I notice a voltage difference across them, and they're not supposed to be a capacitor, then I can assume that's a blown fuse. I'm going through this, and I'm slowly piecing it together. This chip doesn't seem to have any functions to stop it. I don't know anything about that chip. That seems just to be a transistor. These are MOSFETs. There's no components on the board that seem to really be a fuse. This resistor is perfectly fine. Must be for the discharge. Maybe they connect it to that to discharge whichever cell needs balance. And then I notice that this is the battery's negative. This pin goes to here, and then this pin goes on the back of the board and comes down to this transistor. So this might be what turns the entire thing on. The chip has power. It is powered up. It's outputting signal. It wants to work. Something is stopping it from working. I don't know about... This one's having power too. I'm thinking there's something with this sensor. Like maybe it went bad. Maybe it went bad and just stopped the battery from charging. And so it didn't actually go bad. It just... Something broke. The thing just stopped charging and it just died over a decade. I've traced the pins from 1 and 2. 1 goes to, let's see, this one, and 2 goes to this one. This is the discharge control MOSFET, and this is the charge control, or FET, or whatever it is. Oh yeah, it is a MOSFET, right. So these two aren't an issue, but I'm perplexed by this, because it seems like this is the main thing keeping this from connecting to this. So like, this is negative, and this is the power negative pin, and those need to be connected, and these two aren't low. Huh. So if I just jump those two pins, connecting these two pins together, bypassing this, then it works. Before, when I was doing the jumper, I was basically taking the negative pin on the inside of the battery and jumping it to the negative pin on the outside of the battery. But right now what I'm doing is I'm taking this like control pin and jumping it to that. Right, so I'm gonna have to actually solder that. Now I don't just want to solder it over, because I realized I have a bunch of other laptop battery packs that probably have thermal fuses in them that haven't blown. Some of these old packs did get a bit brittle. It's nice, because then like with that one it breaks apart nicely, but if you're gonna do this, make sure you have an open window or something, so if this thing catches on fire you can throw it outside. But I was able to pop it by putting it in the vise. I did that with the other one too. And it goes a long way. Nope, that one doesn't have it either. These are all the 2-pin ones. This one's model Grape 32. What? Huh. It's a Sanyo. Okay. It's always a guessing game of how much you can crunch it. But oh boy, is this dangerous. Boy, is this dangerous. Oh, these cells are bad. I can smell that sweet, sweet smell of chemicals. Okay, we're going to try an actual Lenovo cell. Maybe they're similar. Oh. Okay, that's what. The connector's all busted up. Well, I won't feel bad taking that apart then. It's like opening a shelled animal to cook it up. This one smells good. This one doesn't have any like chemical-y venting smell. Is that the same thing? I don't know if that, I don't think that is, but could it be? Toshiba. If any of you guys want lithium-ion batteries, let me know. I might just sell these because once you get known as a person who likes using old batteries, they just kind of collect there. Why do you do this to me, Dell? Why? Didn't really think about it being glued down, so hey, it is a fuse. So it says SE fuse on it, and then D6X08A. So it's SE fuse. You know, I wonder if, since it has 3 pins, if it's more like a transistor where it's only on once it has power. But it's a thermal fuse, so it can't be. All that trouble for that. Gosh, that is quite a rare component. I guess they don't put thermal fuses in most batteries anymore. So I just found out on laptop.ro that there's pictures of inside these fuses. So it is, if you decap it, it's just 3 wires with a pin, and they should all be connected. So that fuse had blown. That makes sense, since that one cell had burnt up, it seems. Or not burnt up, but it probably got really hot in order for it to corrode like that. So you can solder onto it in order to do that. That's quite scary. But all this means is that I should be able to just test the resistance across each piece of this, just to see if this is still fine. 1.2 ohm. As opposed to this one, which is, that one's disconnected, and then, yeah, so it's disconnected. So I think that this pin down here, which is the center pin, needs to be this pin, and then these 2 pins need to be these 2 pins. Cut this little wire off this fan. Come on. Damn surface tension. Oh, I hate these pliers. Don't know where they got them. Just found them on the ground in my workshop. 1, 2, 3. And then I'm going to do the first pin first, since it's most flexible. And that's kind of it. So now, after all of this, do we have some power? Okay, okay, okay. Okay, I think there's too much gunk on my connectors or something. So it doesn't work. Damn. Ah, so that's what happened. I've just moved it too much and it's broken. I hate lawn work. I hate lawn equipment. This is an absolutely scary battery. And this is the last thing I'm ever going to do with it. Any more, and that's too much. That one's not working either. Well, fuck it. Fine. I hate this. Fucking hate this. Like, I don't want to use a battery that has no protection circuits whatsoever. But I don't get what's going on. I just don't understand. And there we have power. No excessive voltage being drawn. Oh, look at that. Charging reached 100%. I came on the screen as black. So it still says it's charging. So let's go a little longer, then we'll open it up, see if it's balancing it. Here's the moment of truth. So I went until it said it was 100% and it said it stopped charging. 100%. But the question is, did it stop it at 4.2 volts? That's what I want to know. Man, my pack's looking more and more beat up. But that's what happens when you have to tinker with something. You can't open something more than a few times before other stuff starts breaking. Alright, so before it was what, 2.63 and 2.52? Or 3.63 and 3.52? 4.14 volts. 4.14 volts. And 4.10 volts. That was the one that was low. So it is balancing it. And most of all, it is stopping it at 4.15, which is actually better because for every 0.5 of a volt you go down, that's half of the wear and tear on the cells, so it lasts twice as long. So that actually works. Somehow this pack was able to put up with me tinkering with it. I don't know how, and I know for a fact that if I do any more, it's going to die on me, and I wouldn't trust it. I barely even trust it now. One thing I want to do is I want to take some 4 amp pico fuses and put them along there. I'm going to do that sometime. I can't recall where my pico fuses are though, but it definitely needs a fuse on there. It's a little bit tight, more like snug, but oh well. I probably shouldn't have scraped that across there, but whatever. But it works, and I'm happy. Now to install Windows 2000 and make sure it works even better, so we can actually test it. So I installed Windows 98, and boy does it run a noticeable amount faster. Half-life is a little bit glitchy because it seems like there's some hard drive issues, but NTFS seemed to work a little better. But the full screen one is like twice the frame rate of this fly-by-2, and then it's actually to the point where the original is like 60 FPS, which is pretty cool. Almost a little too fast, but I like it. A little lower frame rate there.
Not a problem, probably, but I'm showing a small discrepancy in, well, no, it's well within acceptable bounds again. Sustaining sequence. Order. Get away from the feet. Shutting down. No. Objective shut down. It's not. It's not shutting down. It's not.
Unforeseen consequences. Oh, I'm dead. Nah! That's funny. I've never died there before. I start the game dead.
Reminder, ladies and gentlemen, the seatbelt sign is illuminated. Please remain seated with your seatbelt fastened. Thanks a lot.
So, it's been a few weeks. I've just edited this video and I really like it. I think it's worthy of a good outro. And I made an animation. I mean, I'll show you the animation, but I think we should go to a park. We should go to Wawa and get some pretzels and stuff. But then I can show the viewers what I've loaded onto this. So we came to the nearest park. We don't really know the parks out here that much. It's a lot of sunniness. And then I realized well, this is a spot for some computing. Watch out for poison ivy right there. What? Well, not too many places, no big rock to sit on, so I guess we could just sit over there. Works. I guess I should sit this way. It comes back a lot faster than my X260. So this is a little animation can you see that fine?
Yeah.
Zoom into this, or just look in closer. Little animation I made. Running in real time too. What's the sound of the fan? Oh no, that's like an excavator way over there. Never mind. So yeah, this can do 3D animations. Let's see, can it do... Let's see if it does solid frame. Okay. You know, not bad. Not bad. I would expect that to be a lot slower. Did I spell it right? Cyberspace? Yeah. I think I did.
You did.
Yeah. So now I of course am using a few little tricks because Blender 2.28 is a lot faster than Blender 2.45, and Windows 98 is a lot faster than Windows 2000. So if I had Blender 2.49 on Windows 2000, that would be like 1 frame per second. But here, it's like 12 frames per second, which is pretty good. And whenever I do gaming, let's see. Should we show them Car Precision Racing, or should we show them Need for Speed?
Need for Speed.
Okay. I've had to reinstall the games on this so many times that... So for the graphics, you I didn't realize that on a lot of these older games they would automatically upscale, so I can do 512 by 384 and that'll be full screen. I don't know where the setting is for the dimness, because like it is brighter on wall power, but you can still have the full speed of the processor on battery. A game like this, which maxes out the system, it will run for about an hour, maybe an hour and 20 minutes. Any game that's lesser, like Doom or whatever, it's 2 hours or more.
2, 1, go!
Get some zoomed out shots on it. Frame rate's pretty good for full screen. It's because it's actually rendering like 1/4 frame, and it's actually rendering that big, and then it blows it up. A lot of these games did that. Half-Life doesn't seem to do that, but Chasm the Rift does. I'm thinking about modifying Windows 98 to accept NTFS, because it seems like NTFS runs a little faster. The FAT32 system has some glitches. Meanwhile, we can have Chasm the Rift. On a game like this is a Ukrainian game, I believe. It just will run for like 2 or 3 hours. Because this game's running at like, it seems like 60 FPS. Despite being released in 1997, I believe. Beautiful game. Using a hybrid of 2D and 3D. This guy's always a pain. We get the armor. I really like, just like any game like this that gives you 3D exploration, and yet it runs at a very high frame rate on this computer. Because it's definitely a step up. Like, look at this quality. This is it might be limited, but it's a lot better than games like Doom and stuff. Well, maybe not. Maybe more like better than Wolfenstein at least. I will say I never have actually played much of Doom. It's hard to play with a trackpad. Track point, sorry. Oh, right. So then, I guess, oh shoot, what else should we can edit video with Adobe Premiere 5. Recording a video now, but it's a tiny, tiny video. There's construction in the background, so you can't hear it. Oh well. So there is some issues with my hard drive. The FAT32 is a bit slow, but I'm working on experimenting with a few unofficial upgrades where you can get NTFS working, because NTFS works fine. Half-Life isn't glitchy or anything. But so I just realized this hard drive I don't have any videos on, because I have Sailor Moon on the other one. I found a way to play full screen video on this, but I guess it's not really, I shouldn't be showing what I've figured out on the thing so far. Really, it's about, I don't need a battery, because, or I don't need a power outlet, because it works on the battery. And after all that fooling around, it's just gone down to 80%, which is going to sit at that for a long time, because anything, as soon as you turn it on, it goes away from 100% and sticks down to 80%. It's funny how a lot of products used to do that. Like the iPhone, it'll stick at 100% for a while. Really, it's like, it says 100% until it's like 95%, just so you feel like it's full. But electronics, they used to be, as soon as you started pulling power from them, it always dipped down below maximum power, if you remember that. Well, shoot, I mean, I have enough power to do whatever I want out here for like an hour or two. If I'm just doing stuff like editing text files, this thing will last 4 hours. I've had it just sitting around. So I guess I'm videoing in computing in the woods. I had to hibernate or something after 2 minutes, and I forgot to set, I've been reinstalling Windows so many times, I forgot to set it to where it doesn't turn off after like a minute and a half. What a finicky system. Oh, system standby after 1 minute. Are you fucking kidding me? No. 1 minute. Oh my god. Because it doesn't like... computers going to sleep is much like humans going to sleep. Sometimes you don't wake up. Or hibernating or whatever it is. So, I now have my childhood dream of a 1990s laptop that actually can work on a battery. Now what the heck do I do with it? Let it be known that I am computing in the forest. I'm still computing with my laptop. And boy, is it heavy. We've moved about 10 feet and still computing. It's still computing. I don't know what to do with it. I never thought this far ahead. Like, I wanted to have a bunch of cool programs made for it. So thankfully I have the Microsoft Visual C++ 6.0 and the MSDN library for Visual Studios installed. So maybe I can make some software to control some Arduino stuff or whatever. I don't really know.
What if you did a montage in the woods with you spinning around with it?
Oh. Like how? Like this?
Not like that. Maybe not like that, huh?
That?
That's perfect. So what are you doing? Computing in the woods.
I am computing with my battery-powered laptop with a Pentium 2. And a 17 gigabyte hard drive that I've already filled up with ISOs and all sorts of stuff.
Do some word processing.
Word processing. Is Notepad++ good enough?
Yeah.
Okay. Ready?
Gosh, the camera has to put on its spectacles.
Oh really? Here, let me grab the camera.
Yeah. I wish I could zoom it out fast as you run toward me.
That's the one thing I've always missed about this. Like you can't do crash zoom.
Yeah.
Oh, I just realized I'm... Do you see what file I didn't realize I was editing? It jumped to autoexec.bat.
Oh!
Uh-oh. Here, let's see what happens when I run it. And save
Oh
it.
no.
Oh, what the fuck? Bad commander file name. That sounds about right. I didn't realize I was fucking up my autoexec.bat. You ready?
Wow.
Wow! The computer may be fast, but am I fast with the computer? phone, do they? Hit the wall.
That looked pretty quick.
All right. Well, can't win them all. Sorry about your shoes, pal. You should
Let me
know.
see.
Got a lot on them.
Ah.
That'll clean up. It's fine. Sorry, pal. Didn't mean to mess with the shoes. So, here, do you want to sit down again? Or do you not like sitting down on that?
I kind of hate it.
Yeah, I know you do. The laptop now runs for at least 2 hours, which is pretty good, off of cells that were scavenged from used laptop battery packs. These laptop cells were from around 2008 to 2012, so they're quite old themselves, but it's funny, a lot of laptop packs, one pack will die and the other two will just, well, they'll wither away, or the whole pack will be thrown away. And it's almost like if you make a battery pack, you have one pack will die, and then the other two will be made of cells that don't die as much, because it seems like cells, either they're going to die in the first year or two, or they're not going to die. And so this is basically made of cells that have already been in a battery pack and were not the ones that failed. And I wonder if that's going to actually give some more longevity to them, because if they're not going to fail after 4 years, after 10 years, they're probably not going to fail after 20 years. They're just going to slowly lose power. And maybe there's something to that, like weeding out the ones that fail sooner. That's pretty much it for Rinoa's cyberspace. I hope you guys enjoyed this video, and the next video I'm going to talk about how to upgrade this laptop from a 300 megahertz laptop to a 366 megahertz laptop. Oh wait, I already did.